Hey, it's Justin here again, and this is Chapter 3, Applying Newton's Laws. A force that is applied at an angle both has a vertical y component and a horizontal, oh, I forgot to put the x there, but a horizontal x component, as shown here. Force Fy, Fx. To find the x component of the force, you want to multiply the force by the cosine of the angle. To find the y component, you want to multiply the force by the sine of the angle. In order to find the resulting motion or acceleration of a system object, we use Newton's second law, which is rewritten in scalar form for both components, acceleration ay and acceleration x. You find acceleration by dividing the sum of the forces by the mass of the object. Depending on the direction and the amount of force of a pull, force diagrams can vary in appearance. Some can look like this. Friction is also considered a force. Static friction occurs when you attempt to pull an object across another parallel plane, but motion is prevented up to a maximum number of newtons. The maximum static friction force. Kinetic friction force occurs when an object slides across a surface. The surfaces exert kinetic friction forces on each other, opposing the motion of one surface relative to the other. These are the friction equations. Now, let's move on to a practice problem. Question 19. At the start of his race, 86 kilogram Olympic 100 meter champion Usain Bolt from Jamaica pushes against the starting block, exerting an average force of 1,700 newtons. The force that the block exerts on his foot points 20 degrees above the horizontal. Determine his horizontal speed after the force is exerted for 0.32 seconds. Indicate any assumptions you made. In this, we should assume that there is no air resistance, no friction, and no obstacles. This is the sketch for the situation. We know that Usain Bolt's initial velocity was 0 meters per second. He exerts a 1,700 newtons of force at a 20-degree angle. So, therefore, we need to find his horizontal component of his, force. So, we need to find the acceleration, and then we need to find his final velocity after 0.32 seconds. Remember that force and acceleration are, related, are proportional. This is the force diagram for the situation. First off, we need to find Usain Bolt's component of his force on the floor, his horizontal component. And by plugging in our numbers, we see that his horizontal component is 1,597.5 newtons. Next, we need to find Usain Bolt's acceleration. In doing so, we know that the only horizontal force acting on Usain Bolt, since there is no friction, is the 1,597.5 newtons of force from our horizontal component of Usain Bolt's thing there. And we also know his weight is 86 kilograms. So to find the acceleration, we do the sum of the forces divided by the mass, and in doing so, we get 18.6 meters per second squared for his acceleration, which is pretty fast. Next, we must find his final velocity after 0.32 seconds. So, in order to do so, we know that Usain Bolt started from rest since he was starting the race. So, These are components for the equation here. After solving everything through, we find that Usain Bolt's speed after 0.32 seconds is 5.94 meters per second. Let us move on to Chapter 4 next.